Now, just now I was saying you that iron, when it reacts with nitric acid, it is going to form nitrate, water and nitrogen dioxide gas will be evolved, but it is going to behave slightly differently. Now what? See, iron and aluminium, listen very carefully. These two elements, they are highly reactive, you know, these elements. What compared to zinc, copper and all, they are highly reactive in nature, iron and aluminium, because they are higher in the metal activity series compared to zinc, copper, lead and all those things. Okay, fine. So as it is highly reactive, it is not only going to form nitrate, listen carefully, it is also going to form oxide. Like iron, when reacts with nitric acid, as I said you, it gives you nascent oxygen to form ferric oxide, Fe2O3. Similarly, aluminium is with nascent oxygen, it gives aluminium oxide. Alright? Aluminium reacts with nascent oxygen. From where you got nascent oxygen? From nitric acid. To give form ferric oxide and aluminium oxide, it is going to form. Now, think of this is a iron rod. When it reacts with nitric acid, what it forms? It forms ferric oxide. So ferric oxide settles over the surface of iron throughout. It settles over the surface of iron. Now when this ferric oxide settles over the surface of iron, and that iron, when it reacts with nitric acid, will it going to react further? No. Why? Because iron reacts with nitric acid to form nitrate, water and nitrogen dioxide. Ferric oxide does not react with nitric acid to form water, nitrate and nitrogen dioxide gas will be formed. Alright, listen carefully. Ferric oxide or aluminium oxide does not react with nitric acid to form, what you can say is that there is nitrate, water and nitrogen dioxide. You will say why? Because this is an insoluble precipitate. Fe2O3 and Al2O3 is an insoluble precipitate which settles over the surface of iron, which settles over the surface of aluminium, and hence it makes the reaction passive. Passive means the reaction stops there. Alright, reaction stops there. So this phenomena is known as passivity or inertness. So there are certain metals like iron and aluminium. Initially, some amount of gases is evolved. Initially, some reaction is going to take place. Why? Because initially, when it reacts with nitric acid, it forms nitrate, water and nitrogen dioxide gas initially. But as an oxide layer, got it, an insoluble oxide, because this is a precipitate, an insoluble oxide layer settles over the surface of iron, settles over the surface of aluminium, the reaction stops. Got it? So this phenomena is known as passivity or inertness. So understand it. So iron and aluminium, they behaves in this particular manner. Why? The reason I said you, because these are the most active metals compared to, you will say sodium potassium. Sodium potassium, so we never take it because the reaction will be highly explosive. It will catch fire. Forget about it. Got it? So below sodium potassium also iron aluminium compared to zinc, nickel, lead, tin, copper, they are more reactive now. So hence they are going to form oxide, and these oxides are insoluble, which settles over the surface of the metal and makes the reaction passive. This is known as passivity or inertness. Now continuing with this properties only, we will see when compounds when they react with it. Got it? With hot and concentrated nitric acid, what it happens? Compounds. Got it? Now, still now we are doing about metals, non-metals and all these things. Alright, now we'll see the compounds. In compounds, we have got two types of reaction with hot and concentrated. One is your oxidation reaction. Got it? So, in oxidation reaction, I am taking here, that is your sawdust. You know what is sawdust? लकड़ी काटने से जो गुंडा निकलता है उसको बोलते हैं sawdust. Alright, so the general formula of sawdust is C6H10O5 whole N, which is the formula of cellulose. Because लकड़ी किससे बना है? Cellulose ही तो बना है. Alright, it is nothing but C6H10O5 whole N. Now when it reacts with nitric acid, HNO3, that is hot and concentrated nitric acid, when it reacts. Alright, you know what is going to form? Nitrogen dioxide, water and carbon dioxide will be formed. Now no need to balance this equation, you can't balance it because I have written here N. N means any number of, this can be. So unless and until you don't know the value of N, you cannot balance the equations. Alright, you can't. Alright, try to understand this particular thing. So in this way, this is a polymer which you will be studying in higher classes in class 12. So what you find is that when sawdust reacts with hot and concentrated nitric acid, it gives you this particular product. So this is what? An oxidized product. So hence the reaction is called oxidation. Now if I take, that is toluene. Now the toluene, the structure is this is a structure of toluene. First let me write the structure. Now this is what? This is benzene. Benzene whose formula is 6H6. Benzene, this formula, this much is your benzene, this much. is benzene. I am adding here CH3. How will I add CH3? I will remove one hydrogen from here. All this point is nothing but CH, 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 CH. And this ring means it is alternately single and double bond. You will study. I will be teaching you in organic chemistry. At that time you will study. So just remember here, that is from C6H6. I am removing one hydrogen and I am putting CH3 group. So when I remove one hydrogen, what it becomes? C6H5. Now CH3. C6H5 CH3 is what? What I can write it down. So you can add it up this one. C7H8. So instead of writing this C7H8, you can write in this way. Okay, understood? I taught you. In your book, you will be seeing it. The C7H8 is there. How did you got C7H8? Understood? This ring is C6H6. This is called benzene. There I am removing one hydrogen from here and I am putting CH3. That means that is when I remove hydrogen from benzene, C6H6, what I get? C6H5CH3. So C6H5CH3 can be written as this C7H8. Got it? Fine. Now, HNO3, same thing, hot and concentrated. Now, this reaction is not called as oxidation reaction. This is known as nitration. Why it is nitration? You will see it. This is not nitration. So what will happen? First, let me draw the structure. What will happen? See here, that is CH3 group is there in the first position. Here NO2 will be added in the second. This is your third. Third will not be added. That is fourth, fifth, and this is sixth will be added in this way. In this way it is being added. Plus what it will be? Water. So how many NO2 I have taken? 3 NO2. Say it will be 3HNO3. So here it will be 3 water. Now what is the name of this product? It is nothing but TNT. What does TNT stands for? Trinitrotoluene. How did you get it? This name of this particular product is toluene. This reactant is not product, sorry, this is toluene. In toluene I am adding 3 nitro group. NO2 is nitro group. It is said to be as. In organic chemistry we call this as nitro. In inorganic we call it as nitrogen dioxide. But in organic chemistry, listen carefully, this thing. In NO2 we call it as nitro group. So how many nitro is there? 3 nitros. It is trinitrotoluene. In toluene we are adding 3 nitro groups. So trinitrotoluene. You can write it in what you can see in this way also. You can write it down. How you can write it in other way? So you can write the product C. What is that? C7H8. Now C7H8. What is C7H8? From there you are removing 3 hydrogen. 1, 2, 3. And in place of that, what I am putting? I am putting 3 NO2 groups. So what you will write it down? C7H5. Instead of H8, it will be C7H5 NO2 whole thrice plus 3 water. Understood? Here I have removed one hydrogen, here I am removing one hydrogen, here I am removing one hydrogen. And instead of that, I am putting, what is that? 3 NO2. So how many hydrogen was there? 8. I have removed 3. How many will remain? 5. So, and I got C7H5 NO2 whole thrice plus 3 water. Alright, actually in higher classes you will be studying in this way only. You will not be studying in this manner because this is a difficult method. When you learn this particular structure, then it's an easy method. You will see that when you learn organic chemistry. In this way it forms trinitrotoluene. This is oxidation reaction which takes place with hot and concentrated nitric acid. That is, one is oxidation, another is nitration. You can say that. Now with cold and dilute, when oxides it reacts. When cold and dilute, let us say non-metallic oxide. When it reacts with cold and dilute nitric acid. For example, sulfur dioxide reacts with water plus nitric acid. Now instead of sulfur dioxide plus water, you can also write H2SO3. You can also write, see, add it up, H2SO3. Alright, you can also write H2SO3. But this is cold and dilute. This is cold and dilute. What is going to happen? You know that in cold and dilute, what I am going to get it? Nitric oxide. I am going to get it, nitric oxide. What more you will be getting it? That is, it will be sulfuric acid. Because just now I said you that sulfur dioxide will be oxidized to sulfurous acid and sulfur trioxide will be oxidized to sulfuric acid. Alright, so here what you find is that you will say that, sir, here sulfur dioxide is there, it should be sulfurous acid, correct? Sulfurous acid, H2SO3, gains one nascent oxygen from where? From here, nitric acid, to give you H2SO4. Alright, again I repeat, sulfur dioxide reacts with what you can say water to form sulfurous acid. As you can see here, sulfurous acid. Now sulfurous acid reacts with nascent oxygen. Nitric acid will give you what? Nascent oxygen. Will form what? Sulfuric acid, and nitric oxide you get it in this manner. Similarly, if you take H2S, if I take another compound, let us say H2S plus nitric acid, if I take it, that is same thing, cold and dilute. Alright, what I am going to get it here? I am going to get it nothing but sulfur plus water plus nitric oxide. Sulfur plus water plus nitric oxide. You can balance it. Sulfur plus water plus nitric oxide. Why? Because same thing. Nitric acid acts as an oxidizing agent. It oxidizes H2S. Loss of hydrogen is known as oxidation. Loss of hydrogen is known as oxidation. So hydrogen sulfide is oxidized to sulfur. See here, hydrogen sulfide is oxidized to sulfur, which is helping in oxidation. Nitric acid helps in oxidation. It gives you nascent oxygen. So hence H2S you get sulfur. Alright? Understand the equation. Always addition of oxygen is not only oxidation. Removal of hydrogen is also oxidation. You know that. So in this way you get sulfur plus water plus nitric oxide, because as it is cold and dilute you will be getting nitric oxide, that is gas will be getting it. Similarly, if you take ferrous sulfate and if you react with nitric acid, you will be getting ferric sulfate. Ferrous sulfate is dirty green color. It will be oxidized to ferric sulfate, which will be reddish brown color. So the equation will be FeSO4 plus H2SO4 plus HNO3. Alright, FeSO4 plus H2SO4 plus HNO3. This is dirty green ferrous sulfate plus HNO3, which will be oxidized to what? Fe2SO4 whole thrice ferric sulfate, which is reddish brown. How do we know that is oxidized? The color changes from the dirty green to reddish brown. That is ferric sulfate plus water plus nitric oxide. You may balance it this one. Later on you can balance it in this way. So this is how what you can say, compounds are also being oxidized under cold and dilute, under hot and concentrated. I hope you understood this particular thing. Thank you.